This is Concept T classes, and today we'll deal with Part 2 of Chapter 3 in Class 9 Science, Atoms and Molecules. So in the first part we saw about the laws of chemical combination, what is an atom, atomic mass, what is a molecule, the molecules of elements and compounds. In this part we'll see how we write a chemical formula, and we'll study about the molecular mass and mole concept. So before we enter into part 2, let's take a quick summary of what all we have studied in part 1. So first we saw the laws of chemical combination, which was introduced by Anthony L. Lavoisier and Joseph L. Proust. They established two important laws of chemical combination. The first one was law of conservation of mass. According to this law, mass can neither be created nor destroyed in a chemical reaction. Then we discussed about the law of constant proportion. Here all the elements in a chemical substance are present in a definite proportion by mass. For example, in the case of water, the ratio of the mass of hydrogen to that of oxygen is 1:8. In the case of ammonia, nitrogen and hydrogen are always present in the ratio 14:3. So according to the law of constant proportion, all the elements in a chemical substance are present in a definite proportion by mass. Then we studied what is an atom, then the symbols of an atom. Then we studied about atomic mass. What is atomic mass? The average relative mass of an atom, of an element with respect to the mass of an atom of carbon-12. Then we also studied that atoms, they cannot exist independently and they retain all its chemical properties. Then we studied what is a molecule. Molecules is the smallest particle of an element or a compound which is capable of independent existence, and it shows all the properties of the substance. Then we studied the molecules of elements and molecules of compounds, and lastly we studied about ion. What was an ion? Ion was electrically charged atom or a group of atoms are called as ions. Negatively charged ions were called as anions, and positively charged ions are called as cations. So this is all what we have studied in part 1. So in part 2, first we'll study how to write a chemical formula. Now what is a chemical formula? The chemical formula of a compound is a symbolic representation of its composition. For example, salt. Salt is made up of sodium and chloride. The chemical formula of salt is NaCl. So the chemical formula of a compound is a symbolic representation of its composition. Now the chemical formula of different compounds can be written very easily. See here, sucrose C12H22O11, acetic acid C2H3O2. So we'll study how we can write this chemical formula. So first we need to know the symbols and the combining capacity of the elements. We already studied about symbols of different elements in part 1. Now what is this combining capacity? The combining power or capacity of an element is known as its valency. So the combining capacity of an element is valency. We know that the atom consists of protons, neutrons and electrons, and every atom wants to be stable. Hence they may either lose or gain or share some electrons. So valency is related to how many electrons are there in the outer shell. For example, in the case of sodium, the valency is 1. In the case of carbon, we have 4 electrons in the outermost shell, hence the valency is 4. In neon, 8. Chlorine, 7. So valency of an element is related to how many electrons are there in the outermost shell. Now valency can be used to find out how the atoms of an element will combine with atoms of another element to form a chemical compound. Say for example NaCl. So valency can be used to find out how the atoms of Na combine with the atoms of Cl to form NaCl. We'll understand more about this point when we see some more examples. Now, the valency of an atom can be thought as hands or arms of that atom. The valency of some common ions are given below. Here we have sodium, potassium, silver, copper. These all are having only one electron in the outermost shell, and hence they are called as monovalent cation because they are all positively charged and they have only one valence electrons. Okay. Now in the case of magnesium, calcium, zinc, iron and copper, they have two valence electrons, hence they are called as divalent cation. They're positively charged, right? So they are called as cation. In the case of aluminium and iron, they have 3 valence electrons, hence they are called as trivalent cation. In the case of non-metallic elements like hydrogen, hydride, chloride, bromide, iodide, these also have only 1 valence electrons and they are negatively charged, hence they are called as monovalent anion. In the case of oxide or sulfur, they have 2 minus, the valence electrons are 2 and they're negatively charged, hence they're called as divalent anion. In nitride, we have N3 minus C 3. So the valence electrons is 3. In the case of polyatomic ions like hydroxide, chloride, they have 1 valent electrons. In the case of carbonate, ammonium, see the valence electrons 2 and 1 respectively. Carbonate, it has 2 valence electrons, and nitrate, it has 1 valence electrons. So these are some of the name and symbols along with the valencies of some ions. The rules that you have to follow while writing a chemical formula are: the valencies or charges on the ion must balance. That is, we have to make both the positive and negative charges the same or equal. When a compound consists of a metal and a non-metal, the name or the symbol of the metal should be written first. For example, calcium oxide, CaO, sodium chloride, NaCl, iron sulfide, FeS, copper oxide, CuO. So here oxygen, chlorine and sulfur, these all are non-metals and they are written on the right, whereas calcium, sodium, iron and copper, they all are written on the left. Now in compounds formed with polyatomic ions, the number of ions present in a compound is indicated by enclosing the formula of the ion in a bracket and writing the number of ions outside the bracket. For example, MgOH2. Whereas in NaOH, how it is written? The number of polyatomic is 1. There is only 1 hydroxide ion. Okay, so the bracket is not required. Whereas in the case of magnesium hydroxide, here there are 2 hydroxide ions. So we use brackets. Okay, that is, we enclose this ion in a bracket and we write the number of ions outside the bracket. So this is how we write a chemical formula. So let's see how to write the formula of simple compounds. Now the simplest compounds, which are made up of 2 different elements, are called as binary compounds. For example, carbon dioxide, it is made up of 2 different elements. H2O, hydrogen and oxygen are 2 different elements. So such compounds are called as binary compounds. Now the valencies of some ions, we already saw it in the last slide. So we can use these to write the formula of different compounds. Now while writing the chemical formula for compounds, first we should write the constituent elements and then their valency. Then we cross over the valencies of the combining atoms. For example, the formula of hydrogen chloride. So first we write the elements of hydrogen chloride. What are the elements? Hydrogen chloride. Then we write their valencies. For hydrogen, the valency is 1, chloride, it is 1. Then we cross over the valencies of the combining atoms. Hence, the formula of the compound would be H, only 1 atom of hydrogen and 1 atom of chlorine, HCl. So this is how we write the formula of simple compounds. So let's see some more examples. Now let's find the formula of the following compounds using the reference of these tables. So the first one is the formula of hydrogen sulfide. So the constituent elements are hydrogen and sulfur. The valency of hydrogen is 1 and sulfur is 2. We cross over the valencies and we'll get 2 atoms of hydrogen and 1 atom of sulfur. Therefore, the formula of the compound hydrogen sulfide would be H2S. Now let's see the formula of carbon tetrachloride. So here the constituent elements are carbon and chlorine. The valency is 4 and for chlorine it is 1. See, we cross over the valencies, we have C1 and Cl4, right? So the formula of the compound would be CCl4. Now in the case of magnesium chloride, it is an ionic compound. So we use or we write the charges of the valence electrons. Okay, so the constituent elements Mg and Cl and the valence electron along with the charges is 2 plus and for chlorine is 1 minus. And when we cross over the valency, we'll get MgCl2. See? Here in this magnesium chloride, there are 2 chloride ions for each magnesium ion. That's why we say that magnesium chloride is an ionic compound, because the magnesium forms an ionic compound to Cl by donating its valence electrons to Cl. So here the positive and negative charges must balance each other so that the overall structure would be neutral. And even if we note the formula, we could see that the charges of the ions are not indicated. We'll study more about this valence electrons in the next chapter. Now let's see the formula of aluminium oxide. The constituent elements of aluminium oxide is aluminium and oxide. The valency of aluminium is 3 and it's written as plus because it is a trivalent cation, and for oxide it is 2 minus. We saw that in that previous slide, right? So we cross over the valencies, we'll get Al2O3. So from here we can understand that just like in the previous example, the charges of the ions are not indicated inside the formula. Now in the case of calcium oxide, the constituent elements are calcium and oxide. The charge is, or the valency for calcium is, it's not given here, I think for calcium it is 2 plus and the oxide is 2 minus. We cross over, we'll get Ca2O2, but we usually write as CaO because the valencies of two elements are the same, C2 plus and 2 minus. Hence we arrived at the formula Ca2O2, but we simplify the formula as calcium oxide. Now to find the formula of sodium nitrate, first we write the symbols of the constant elements sodium Na and nitrate NO3. Then the valency along with the charge for sodium is 1 plus and for nitrate is 1 minus, NO3 minus. Okay. Then we cross over the valencies. Here also the valencies of the two elements are the same. Hence the formula of sodium nitrate would be NaNO3. Now the formula of calcium hydroxide. The constant elements are calcium and hydroxide. The valence electrons of calcium is 2. The charge is plus, it is a cation. Hydroxide, it is 1 minus. We cross over the valency and we get the formula of the compound as calcium hydroxide. See here, if you note the formula of calcium hydroxide, it is written as CaOH twice. It is not written as COOH2. Here we use the brackets when we have two or more of the same items. We have two OH ions. So here this OH2 indicates that there are two hydroxyl groups joined to one calcium atom. Now let's see the formula of sodium carbonate. So here the symbols are sodium and carbonate NaCO3. The valence electrons are 1 plus and 2 minus. We cross over the valencies and here we'll get Na2 and CO3. See? So this is the compound. As we saw in the previous examples, the charges on the ions are not indicated in the formula. For ammonium sulfate, we have the following constituents. For ammonium, which is NH4, and sulfate, it is SO4. The valence electrons for ammonia is 1 plus and SO4 is 2 minus. Then we cross over, the formula of the compound would be NH4, 2 and SO4. Okay. Now let's see about the molecular mass and mole concept. Now what is a molecular mass? The molecular mass of a substance is the sum of the atomic masses of all the atoms in a molecule of the substance. So just like the atomic mass is a mass of an atom, molecular mass is a mass of a given molecule which is equal to the sum of the masses of all the atoms that are contained in that molecule. Say for example sulfur dioxide. So it has one atom of sulfur with two atoms of oxygen. So the atomic mass of sulfur is 32.07 AMU and that of oxygen is 16 AMU. But we have two atoms of oxygen, therefore we multiply it with 2. Now we add these two to get 64.07 AMU. So the molecular mass of sulfur dioxide is 64.07 AMU. So the molecular mass of a substance is the sum of the atomic masses of all the atoms present in a molecule of that substance, and it is therefore the relative mass of a molecule expressed in atomic mass unit. So let's see an example to understand more about this molecular mass. So first we have to calculate the relative molecular mass of water, H2O. So we know that the atomic mass of hydrogen is 1U. Atomic mass of oxygen is 16U. So the molecular mass of water is H2O, 2 atoms of hydrogen. So 2 into 1 plus 1 into 16, which is equal to 18U. Now let's calculate the molecular mass of HNO3. So the molecular mass of HNO3 is the atomic mass of hydrogen plus the atomic mass of nitrogen plus 3 into the atomic mass of oxygen. So the atomic mass of hydrogen is 1, atomic mass of nitrogen is 14 plus 3 into atomic mass of oxygen is 16, which is 48. So the molecular mass of hydrogen nitride is 63U. So like this we can calculate the molecular mass of a compound. Now let's see what is formula unit mass. Now the formula unit mass of a substance is the sum of the atomic masses of all the atoms in a formula unit of a compound, or in simple words, the formula unit mass is the sum of the atomic masses of all the atoms present in the formula of a respective compound, and the formula unit mass is calculated in the same way as we calculate the molecular mass. Say for example, how do we calculate the molecular mass of NaCl? We calculate the atomic masses of sodium 23 plus chloride 34.5, which is 58.5U. So the same way we calculate the formula unit mass. The only difference is that we use the word formula unit for those substances whose constituent particles are ion. That is, the formula unit mass is used for those substances whose constituent particles are ions. Say for example, sodium chloride. We just now saw, right? It has a formula unit of NaCl, 1 atom of sodium, 1 atom of chlorine. So the formula unit mass can be calculated as 1 into 23. Atomic mass of sodium is 23 plus 1 into chlorine. Atomic mass is 35.5, which is equal to 58.5U. Similarly, to calculate the formula unit mass of calcium chloride, we calculate it as atomic mass of calcium plus 2 into atomic mass of chlorine. That is, atomic mass of calcium is 40 plus 2 into atomic mass of chlorine is 35.5, which is equal to 40 plus 71, which is equal to 111U. So in this way we can calculate the formula unit mass of different compounds. Now let's understand about the mole concept. So first let's consider the reaction of hydrogen and oxygen to form water. 2H2 plus O2 gives 2H2O. So from this above reaction, what can we understand? 2 molecules of hydrogen combine with 1 molecule of oxygen to form 2 molecules of water. Okay, we know that to form 1 molecule, 1 H2O, we require 2 atoms of hydrogen and 1 atom of oxygen. So if you want to get 2 molecules of water, what should we do? We require 2 molecules of hydrogen combined with 1 molecule of oxygen to form 2 molecules of water. Now in the terms of atomic mass, we can write 4U of hydrogen molecules, because we know that the atomic mass of one hydrogen atom is 1U. So here 4 atoms are used, so 4 into 1, which is 4U. In the case of oxygen, the atomic mass of one oxygen is 16U. 2 atoms of oxygen are used here, therefore 32U of oxygen molecules, they form 32 plus 4, 36U of water molecules. Okay, so from this above reaction we understand these 2 points, or in simple words we can say that if we require 1 molecule of water, we need 2 hydrogen atom with 1 oxygen atom. If we require 2 molecules of water, we require 4 hydrogen atom and 2 oxygen atom. Now if we require 5 molecules of water, we require 10 hydrogen atoms and 5 oxygen atom. So from this we can understand that the quantity of a substance can be characterized by its mass or the number of molecules. But a chemical reaction equation indicates directly the number of atoms or molecules taking part in the reaction, right? We don't deal with the masses. For example, here methane, it reacts with oxygen. See, CH4 plus 2O2 gives carbon dioxide with water. So in a chemical reaction equation, it directly deals with the number of atoms or number of molecules taking part in the reaction rather than their masses. Therefore, a new unit called as mole was introduced. Now the mole symbol MOL is the SI unit of mass substance, and 1 mole is actually equal to 6.02114076 in 10 raised to 23 elementary entities. Elementary entities mean it can either be ions or molecules or particles. Okay. Now the number is fixed numerical value, and this value is termed as Avogadro constant Na, which is expressed in the unit mole raised to -1, and it is also called as Avogadro number. So a mole is equal to 6.023 into 10 raised to 23 elementary entities. It can either be ions or atoms or molecules, and it is also called as Avogadro number or Avogadro's constant. So we saw that the mole was introduced in order to refer the amount of a substance or quantity of a substance in terms of molecules or atom. Now this amount of substance is symbolized as N, and it is a measure of the number of specified elementary entities. What do you mean by this elementary entities? It can either be atoms or molecules or ion. Hence we can define mole as the amount of substance of a substance that contains 6.0221 into 10 raised to 23 specified elementary entities. That is, mole is equal to mole of anything is equal to 6.022 in 10 raised to 23 in number. Just like we use a standard, like for 1 dozen we know it's 12 numbers, 1 gross we know is 144 numbers. Similarly, 1 mole of anything is equal to 6.022 into 10 raised to 23. Okay. Now beside this, the mole has one more advantage, that is the mass of 1 mole of a particular substance is always fixed. So the mass of 1 mole of a substance is equal to the relative atomic mass or molecular mass in grams. That is, we know that the atomic mass of an element gives a mass of 1 atom of that element, right? For hydrogen, the atomic mass is 1. Similarly, the molecular mass is the sum of the atomic masses of all the atoms which is present in the molecule of that substance. So the mass of 1 mole of a substance is equal to this relative atomic mass or molecular mass in grams. So to get the mass of 1 mole of an atom of that element, that is a molar mass, the mass of 1 mole of an atom is also called as molar mass. We have to take the same numerical value but change the unit from U to G. Now the molar mass of atoms is also called as gram atomic mass. Let's take an example. Now we know that the atomic mass of hydrogen is 1 U. So the gram atomic mass of hydrogen is, we have to just change the unit from U to G. So from this, what can we understand? That 1 U hydrogen, that is 1 atomic mass unit of hydrogen has only 1 atom of hydrogen, whereas in 1 gram of hydrogen, that is 1 gram atomic mass of hydrogen, it has 1 mole atoms, that is 6.022 into 10 raised to 23 atoms of hydrogen. Similarly, 16U, it has only 1 atom of oxygen, okay, but 16 grams of oxygen, it has 6.022 into 10 raised to 23 atoms of oxygen. So just like we saw the gram atomic mass, that is a molar mass of an atom, we also have a molar mass of a molecule. So in order to find the molar mass of a molecule or the gram molecular mass, we keep the numerical value the same as that of the molecular mass, but we simply change the unit from U to G. That is, to find the gram molecular mass, we do the same calculation as how we find the molecular mass. We just have to change the unit from U to G. Say for example the molecular mass of water. It is 18U. How did we find the molecular mass of water? We know that the atomic mass of hydrogen is 1U, atomic mass of oxygen is 16U. So the molecular mass of water is H2O, sum of all the atomic masses of all the atoms present in that molecule. Therefore 2 into 1 plus 1 into 16, which is equal to 18U. So from this we can understand that 18U water has only one molecule of water, right? So to find the gram molecular mass, we convert this U to G, and from that what can we understand? 18G of water has only 1 mole molecules of water, that is 6.022 into 10 raised to 23 molecules of water. Now chemists, they need the number of atoms and molecules while carrying out the reaction. That is, we know that the chemist, they want to measure the quantity of matter, but the matter consists of different elements and each elements have a billions of atoms. So the chemist, they uses mole as a unit for the amount of a substance, okay, and they need to relate the mass in grams to the number. It is done as follows: 1 mole is equal to 6.022 in 10 raised to 23 number, which is equal to relative mass in grams. Thus mole is the chemist's counting unit. Now the word mole was actually introduced around in 1896 by Wilhelm Ostwald, who derived the term mole from the Latin word moles, meaning a heap or a pile. Now a substance may be considered as a heap of atoms or molecules. So the unit mole was actually accepted in 1967 to provide a simple way of reporting a large number, the massive heap of atoms or molecules in that sample. So let's consider some examples to understand the concept of molar mass, the number of moles in detail. So the first example is to calculate the number of moles for the following. 52 grams of helium is given. We have to find the mole from this mass, and the second part is 12.044 in 10 raised to 23 number of helium atoms. We should find the mole from this number of particles. So these are the number of helium atoms, and from this particles we have to find the mole. So for the solution, we have the number of moles, which is equal to N. The given mass of that substance, which is helium, is M. Molar mass is M. Given number of particles is N, and Avogadro number of particles is Na. So in the first case, 52 grams of helium is given, and we have to find the number of moles from the given mass. So for this, we know that the atomic mass of helium is 4U. Okay, hence the molar mass of helium can be written as 4G, because we know that to find the molar mass of atoms, we just have to replace U with G. The numerical value would be C. Now we know that the molar mass is the mass of the given substance in grams divided by the number of moles, or the amount of the substance in moles. Therefore, if we want to find the number of moles, we have to divide the mass of the substance by the molar mass. Hence, number of moles is equal to given mass by molar mass, which is equal to N M by M. So the given mass is 52 grams divided by the molar mass is 4 grams. Hence, the number of moles is 13. Okay. Now the second part was we have the number of particles, that is 12.044 into 10 raised to 23, and we have to find the mole from the number of particles. So we know that 1 mole is equal to 6.022 into 10 raised to 23. So in order to find the number of moles, if the number of particles is given, the equation is number of moles is equal to given number of particles divided by Avogadro's number. That is N is equal to N by Na, which is equal to number of particles is given 12.044 into 10 raised to 23 divided by 6.022 into 10 raised to 23, which is equal to 2. Okay. So in order to find the number of moles, we divide the given mass by molar mass, and if you want to find the number of moles, if the number of particles is given, we have to divide the given number of particles with the Avogadro's number. Now let's see example 2. We have to calculate the mass of the following: 0.5 mole of N2 gas. We have to calculate the mass from the given mole of a molecule. Here 0.5 mole of N atoms. Mass from mole of an atom. Then 3.011 into 10 raised to 23 number of n atoms. That is, we have to calculate the mass from the number of particles, then 6.010 raised to 23 number of N2 molecules. We have to calculate the mass from the number of N2 molecules. Okay, so just the same, the solution is the number of molecules is N, given mass is M, molar mass is M, given number of particles is N, and Avogadro number of particles is Na. So let's solve the problem. So in the first case, we have to calculate the mass from 0.5 mole of N2 gas. We know that molar mass is equal to the mass of a substance in grams divided by the number of moles, or the amount of substance in mole. So in order to calculate the mass, we multiply molar mass with number of moles. Okay, so mass is equal to molar mass into number of moles. So here the molar mass of N2 gas is 28. We know that the atomic mass of N nitrogen atom is 14. Okay, so here it is N2 gas. It is an N2 molecule, nitrogen molecule. So the molar mass of N2 is 28 into the number of moles is given here 0.5. So the answer is 14 grams. Now in the second case, we have to calculate the mass from 0.5 mole of N atoms. So here also the same equation is applied. Mass is equal to molar mass into the number of moles. That is, the molar mass of N atom is 14 into the number of moles is given in the question, which is 0.5. Hence the answer is 7 grams. Now in the third case, we have to calculate the mass from 3.011 into 10 raised to 23 number of N atoms. So the number of particles is given. Hence, how can we find the number of moles? Number of moles can be found out by dividing the given number of particles with the Avogadro number. That is 3.011 into 10 raised to 23 divided by 6.022 into 10 raised to 23. Hence, we'll get the number of moles. But what should we calculate? We should find the mass. Therefore, we multiply this N, the number of moles, with the molar mass of N atoms. That is 14 into this number, which is equal to 7 grams. Now in the last case, here we have to calculate the mass from 6.022 into 10 raised to 23 number of N2 molecules. So here also first we have to find the number of moles from the given set of number of molecules. Hence we have N by Na, which is equal to 6.022 into 10 raised to 23 divided by 6.022 into 10 raised to 23. But we have to find the mass. Therefore, we multiply it with the molar mass of N2 molecule. This is 28 into 6.022 into 10 raised to 23 divided by 6.022 into 10 raised to 23, which is equal to 28 grams. So in example 3, we have to calculate the number of particles in each of the following. We have first one is 46 grams of sodium atoms, 8 gram of oxygen molecules, and 0.1 mole of carbon atom. Okay, so the first case is we have to calculate the number of particles from 46 grams of sodium atom. So in order to calculate the number of atoms, we have this equation: given mass by molar mass into Avogadro number. Now how did we get this equation? Let's see. We know that molar mass is equal to the mass of the substance in gram divided by the amount of substance in moles, that is number of moles. Hence we can calculate the number of moles as mass of the given substance divided by molar mass. This is equation number 1. Okay, now in the last exercise we saw that if the given number of particles are there, then the number of moles is equal to number of given particles divided by Avogadro number. So let it be equation number 2. So here these two are the equations to find the number of moles. So let's equate this equation. Mass by molar mass is equal to number of given particles by Avogadro number. So in this question we have to find the given number of particles. Hence the given number of particles is equal to this mass divided by molar mass into Avogadro number. See, that's how we get this equation. So here the given mass is 46 gram. So 46 gram divided by molar mass of sodium is 23 into Avogadro number 6.022 into 10 raised to 23, which is equal to 12.044 into 10 raised to 23. Now in the second case, we have to calculate the number of molecules from 8 grams of oxygen. Okay, so here also the same equation, the number of molecules is equal to given mass by molar mass into Avogadro number. So the given mass is 8 gram. Okay, now the molar mass of oxygen molecule, we have to find that out. The atomic mass of oxygen is 16U. The molar mass of oxygen molecule is 16 into 2, which is equal to 32 gram, because in oxygen molecule there are 2 atoms of oxygen. Okay, so we multiply the atomic mass of oxygen with 2, we'll get 32 grams. So the number of molecules is equal to the given mass 8 grams of oxygen divided by molar mass of oxygen into Avogadro number 6.022 into 10 raised to 23, which is equal to 1.51 into 10 raised to 23. Now in the third case, we have to find the number of particles from 0.1 mole of carbon atom. So the number of particles is equal to the number of moles of particles into Avogadro number, that is equal to 0.1 is the number of mole into 6.022 into 10 raised to 23, that is equal to 6.022 into 10 raised to 22. So that's all for chapter 3, atoms and molecules. If you have any doubts concerning any of the topics, message me in the comment section. Tune in soon for the next session. Till then, take care, stay safe. Thank you so much. May God bless you all. Bye-bye.